Alright, so first let's start by importing the libraries. That's easy, done. Next step, we import the dataset, and we can now because we have the dataset uploaded in our notebook. So make sure to have it as well. Okay, now the dataset is imported. We have the matrix of features and the dependent variable vector y. Good. And now I'm going to do a print to show you the state of x. What is x exactly at this stage. So I'm going to do print x, and I'm going to run the cell. All right, and let's see what we get. All right, so indeed, we get exactly the same columns as in this dataset, with first R&D spend, then administration spend, then marketing spend, and state, right? We can clearly see that we get the same columns here in the same order. All right, so that's the matrix of features, all good. Now, I'm not going to show you the dependent variable vector because that's obvious. We're going to get the same profit. But what I want to show you is what becomes x after we encode the categorical data, and you can actually guess what it will become, but you will see that the 3 columns resulting here from one hot encoding will actually be placed at the beginning. All right, so let's check it out. Let's run the cell to indeed apply encoding categorical data. And now let's create a new code cell in which we're going to print x again, and let's run this cell to see what x becomes. And there you go, exactly as I told you. We have the same 3 first columns here, so that corresponds to R&D spend, that corresponds to administration spend, and that corresponds to marketing spend. But now, instead of having this state column here, we indeed have these 3 new columns at the beginning encoding that state variable. And we can actually see what corresponds to what. If we have a look at our data set, well, the first row has New York as the state, and therefore New York was encoded as 0, 0, and 1. Then let's see, as a second state of the second row, corresponding to the second start, we have California, and therefore California was encoded as 1, 0, and 0. And finally, well, Florida was encoded as 0, 1, and 0. All right, so that's the one hot encoding that happened. And now all good, we have a fully pre-processed data set. And as I told you in part 1, but I'm going to say it again here because this is important, we don't have to apply feature scaling. Why? Because, in the equation of the multiple linear regression, you have this coefficient that is multiplied to each independent variable, each feature, and therefore it doesn't matter that some features have higher values than others because the coefficients will compensate to put everything on the same scale. And therefore, remember this, in multiple linear regression, there is absolutely no need to apply feature scaling. And one last thing I would like to add as well, because I know a lot of you asked this question, do we need to check the assumptions of linear regression? The answer is absolutely not, because I will explain at the end of this part, part 2 regression, that whenever you have a new data set and you want to experiment with some machine learning models to figure out which one leads to the highest accuracy, well, even if your data set doesn't have linear relationships, you can still try a multiple linear regression on it. And if your data set doesn't have linear relationships, well, your multiple linear regression model will just perform poorly, and therefore it will get an accuracy lower than the accuracies of your other models. So you will just not select the multiple linear regression model, but you don't have to check the multiple linear regression assumptions. It will just be a waste of time. Really, I will show you at the end how you can so fast and so efficiently try each of the models on your dataset and select very quickly the one that has the highest accuracy. All right, so I just wanted to be clear on that point. Don't worry about the multiple linear regression assumptions. If your dataset has linear relationships, then good. Your multiple linear regression will check the assumptions indeed and will bring to you a high accuracy. And if your dataset doesn't have linear relationships, well, fine, your multiple linear regression just will perform poorly and you will just take another model. And that's it. That's as simple as that. All right, so now good. We're done with data preprocessing. We can therefore move on to the next step, which is to train the multiple linear regression model on the training set. So take a little break here, and as soon as you're ready to build your next machine learning model, well, join me in the next tutorial to tackle this. And until then, enjoy machine learning.